Hey guys, welcome to Chapter 8. Um, Chapter 8 is pretty cool because we're going to learn something completely new and different this year, which is something called a logarithm. And a logarithm is the inverse of a exponential function. But before we can get there, we need to work with exponential functions a little bit as well. And I combined sections 8.1 and 8.2, so you'll see for your homework tonight that half the problems come from each section. Um, and in 8.1 and 8.2, we're going to focus on graphing exponential functions. This is completely review from Algebra 1 for those of you that did Algebra 1 at Eagle with me. But it's also important to remind ourselves exactly how this works. So please use graph paper for your notes today as well as for your homework tonight. As soon as you've got your note sheet set up, go ahead and move forward. All right, so we're going to start with a review from Algebra 1. What is an exponential function and what do the different parts represent? You might want to try this on your own before you listen to me do it to see if you can remember any parts of it. All right, so the exponential function is y equals a times b to the x. Exponential function because the variable is in the exponent. In this case, a represents the y-intercept, and b represents the multiplier, which is also often called the common ratio. So when we're looking at our graphing today, we're going to be looking at what happens with different types of y-intercepts and different types of multipliers. We're going to review by just looking at the function f of x equals 3 times 2 to the x. And the easiest way to kind of just generalize the shape of this is to make a table of values from -3 to 3, plot them, and sketch the graph. So you might want to make this table in your notes as well. I'll fill it out here. So I've got my x coordinates, plug them into the function to get my y coordinates. So -3 would be 0.375. -2 would be 0.75, -1 is 1.5, 0 is 3, 1 is 6, 2 is 12, and 3 is 24. So if I go to plot these points on the graph, I would put in -3 and about 0.375, -2, -1, 0, 3, 1, 6, and we'll go 2, 12, and we won't put the last one on our graph. So now if we go to connect these, one thing to remember is that exponential functions will never touch or cross the x-axis. In this case, the x-axis is representing a horizontal asymptote, which I will draw in as well to indicate that. So this would be just a sketch of our exponential function where both the y-intercept is positive and the multiplier is greater than 1. There's 4 cases here that we're going to look at today, and this is just the first one. Now, on your homework, you do not need to plot more than one point. The only point you're going to plot is the y-intercept or the transformed y-intercept, and the rest of it will be a sketch that just needs to be going in the right direction and approach the asymptote. So, for example, if we look at another one, f of x equals -3 times 2 to the x, what I'd like you to do is see if you can sketch a graph of this function in your notes before you resume the video. See if your prediction is correct. All right, so in this case, the -a value here represents a reflection over the x-axis. So when we go to sketch our graph of this, we're going to have a y-intercept of -3, and we are going to have a curve that reflects the last curve over the x-axis, and again we have an asymptote along the x-axis. So that's our second case, a -a value and a b value greater than 1. Let's look at a case where we have a positive y-intercept, but a b value that is between 0 and 1. And one thing that you might remember from Algebra 1 is that the b value, the multiplier, has to be positive. It cannot be negative and still represent an exponential function. So if what I'd like you to do is, I bet you can make a prediction. Try it without filling out the table. See if you can sketch what this one would look like in your notes and then resume the video. All right, so we have a y-intercept at 3. But this time, because we're multiplying by 1/2 every time, the values are getting smaller as we move further and further to the right. So our graph would start high and move towards the x-axis as we move further and further to the right, where our x-axis is still being represented by an asymptote. And then our last case here is the case where we have a negative y-intercept and a multiplier that's between 0 and 1. Again, see if you can sketch this in your own notes before you resume the video. All right, so in this case we have a y-intercept at -3. And because we're multiplying by 1/2, every time we multiply to the right, our values are going to get closer and closer to 0. So I'm going to start very low and then move up towards the x-axis as I'm multiplying by 1/2 every single time. And this is all I need to see on your homework, is that one point in the sketch of the curve. So to summarize here, our 4 cases. We had 2 cases where y equals ab dx when b is greater than 1. And those are the 2 cases shown here, depending on whether your a value is greater than 0 or your a value, in other words, your y-intercept, is less than 0. So this would be a picture that would be really good for you to sketch in your notes to reference. Similarly, we've got the same situation, except when b is between 0 and 1. And in those cases, like we just discussed, our curves are going to, as we move to the right, our curves are going to approach the horizontal asymptote along the x-axis. And whether you're on the blue curve or the red curve simply depends on whether your y-intercept is positive or negative. All right, so our last example today is what to do when you also have transformations. So we have the function y equals 4 times 2 raised to the x minus 3 plus 2. And so some things to note here. The x minus 3, that represents a horizontal shift to the right 3 units. The plus 2 represents a vertical shift up 2 units. So the way that we're going to graph this is we're going to start with our y-intercept of 4. And then we are going to move that y-intercept to the right 3 and up 2. And once we've done that, I'm going to erase the original y-intercept. Now, because we have a vertical shift up 2, we also have to shift our asymptote up 2 units. And then when we go to sketch in the curve, the last decision we have to make is based on whether the multiplier is greater than 1 or between 0 and 1. In this case, it's greater than 1, which means as we move to the right, our values are going to get further away from the asymptote. And I would sketch in my curve kind of like that. So that is really, this is all the pieces put together, where you have to choose between the 4 cases and then also account for the horizontal and vertical shifts. So that brings us to the end of the video. Remember that the homework is going to be from 8.1 and 8.2, so be careful when you're looking at the assignment sheet, and make sure you use graph paper on your homework. Let me know if you have any questions.